Okay, class, today we are going to examine a lesson on magnetism and electricity. We have looked a lot at electricity, and now we're going to look at how electric currents and magnets exert forces on each other. And there are different devices that we're going to investigate and look at in this particular lesson to be able to explain how currents and magnets exert forces on each other and examine the relationship that these two concepts share. Okay? Let's first look at a magnetic field. A magnetic field, first of all, when you think about a magnetic field, let's think about magnets. And at some point in our lives, we've all played with magnets or used magnets for some reason. A magnet has or behaves in such a way that if you have two magnets facing each other, sometimes they'll come together, which is an attraction, or sometimes they'll push away, which is a repulsion. Well, that happens because of what is called a magnetic field. A magnetic field surrounds a magnet and it exerts a force on other magnets. So whenever you're holding these magnets at a certain distance from each other and they stick together or they push away from each other, that's because of this magnetic field. A magnetic field is always strongest closest to a magnetic pole and weaker as you move further from the poles. A magnetic pole is the ends of a magnet. On a magnet, they will often be marked with an N and an S, which represents the North Pole and the South Pole. And these are the areas where the magnetic field is the strongest. If you'll notice here, your magnetic field lines are close. And then as you move away from those magnetic poles, those lines start to spread further apart from each other, which is an indication that it's getting weaker. But that is the reason for the way that magnets behave the way they do. It's because of the magnetic field that surrounds them. Magnetic fields can be produced by moving electric charges. So when we were talking about current in our last lesson on electricity, we talked about the fact that when you're building circuits, you have current that's running through your wires that causes the devices in the circuit to operate and to work. Well, around that wire where that current is actually flowing are magnetic fields. Magnetic fields can be produced around that wire because of those moving electric charges. Okay, let's examine our first device. How can current make a magnet? This first device that we're going to look at is called an electromagnet, which is just basically a current-carrying wire. It's wrapped around an iron core. And once you connect these pieces to an energy source, such as a battery, you are going to create a magnetic field around this wire, which in turn creates a magnetic field around this iron nail, which will then magnetize this iron nail. Remember, I just told you that magnetic fields can be produced by moving electric charges. So once I am moving current through this wire, you are producing a magnetic field, which is around this iron core, and it will make this iron center become magnetized. These electromagnets are found in a lot of things that we use. For example, a doorbell. You also find them in speakers. You also find them on, if you've ever seen on TV, where they have these huge machines on like, for example, like a junkyard where they have cars that they crush. They'll pick them up with these huge machines, which is actually an electromagnet. They have this huge piece of iron that they have a current carrying wire wrapped around it, and once they push current through that wire, then it magnetizes that iron piece, and they can pick it up, and then when they get it to the location where they want it to be, they can drop it. So that's just another place where you might find an electromagnet, but they are very useful, and they're found in a lot of the devices that we use. What are some other examples of how electric currents and magnets exert a force on each other? Two other examples that we're going to look at is a motor and a generator. A motor is any device that uses a magnetic field to turn electric energy into kinetic energy. So the energy transformation that occurs with a motor is it takes electricity and changes it into motion. There are lots of devices that we may find a motor in. Probably the most obvious one that you're thinking of is a car. But you also find them in things like ceiling fans. They are found in computers because computers have little mini fans in them that have to cool down the parts from time to time. You find them in your heating and air conditioning units. They're found in a lot of things that we use. But the technology behind a motor is just basically currents and magnets. To keep a motor running, the current carrying wire is formed into a loop so the magnetic field can force the wire to spin continually. If you look at the picture, this yellow part here that's formed into a loop, that's your current carrying wire, which is inside of a magnetic field. This wire is hooked up to an energy source, which in this picture is your battery. And once current is moving through this wire, it's going to push, this wire is going to be pulled, and it will begin to spin continually. And that's how a motor basically works. It's just working off of electric currents and magnets. This is a picture of a motor spinning. And what you have here is you have your magnet. This is where your north and south poles are. And the blue part is your current carrying wire. And it is connected to, or this current carrying wire is formed into a loop. This is the wire as well, and it will force it to spin continuously. Another example of how magnetic fields and currents work together is a generator. A generator is a device that uses a magnetic field to turn motion into electricity. So it's doing the opposite. Now it's taking kinetic energy or motion and it's changing it into electrical energy. If you look in your picture, you have the same components that you had in a motor, except this time it's working in the opposite direction. You've got this current carrying wire. It's formed into a loop and it's inside of a magnetic field. This magnetic field is going, or there is some type of source that's spinning this loop, okay? And in this particular picture, you've got this part right here which spins, and it will force this loop to spin. And as this loop is spinning, you're going to be able to push current through this wire, which will then eventually power this particular lamp that's in the picture. A magnetic field exerts a force on the moving electrons that pushes them along the wire, creating an electric current. So the electrons are already there, and what you're doing by spinning this wire is you're pushing them through the wire, which is creating the electric current. Generators are the source of how we get electricity in our homes. There are huge generators inside power plants, and they have these basic components, magnets and current carrying wire, which is producing the electricity that we get. You can also find generators on a much smaller scale that you can use for your homes. Sometimes people may purchase a generator, especially if they live in an area where hurricanes occur quite often, and they might have a generator on hand just in case the power goes out, and it can power their houses. But that's a smaller scale generator, but they all pretty much work the same way. And you have to have some type of source that's going to turn this loop of wire. In the power plants, a lot of times they may burn some type of fossil fuel like coal, which will produce steam, and that steam in turn can turn what is called a turbine in a generator. And the turbine is inside the generator, and it spins, and that's when the electric current will get pushed out across the wire. But that's just another example of how currents and magnets work together. That concludes our lesson on magnetism.